let's talk about the hidden world of giant electrical switches. It's fascinating, I promise.
So what's worse, a surprise blackout when you really need the power?
Or how about power that just won't shut off, even in a disaster?
Well, that's the exact choice engineers have to make when designing these systems. It all comes down to two little devices, the shunt trip and the undervoltage release.
The shunt trip is kind of like a fire alarm. It does nothing until it's told to act.
And here's the core difference. One needs power to trip, the other trips when it loses power. The undervoltage release, or UVR, is like a dead man's switch. Let go, and everything stops.
So the shunt trip just waits for a direct command. It's designed not to act by mistake.
The UVR's default is power on, but any interruption and boom, it trips.
And get this, look at how they use power. One takes a huge gulp, the other just sips.
Okay, but here's where it gets really interesting, when things go wrong.
Here's the bottom line. One fails by staying on, the other fails by shutting off.
So there's no single best choice here. It all just depends on the situation.
If a shunt trip fails, that breaker stays closed, no matter what.
But if a UVR fails, the breaker trips, even if it's a false alarm. Which brings us to the million-dollar question. Which one of these risks is actually worse?
Let's say a surprise power outage would be an absolute catastrophe.
That's why data centers use shunt trips. They can't risk a glitch causing a total blackout.
But what if power must shut down, guaranteed, if you lose control?
And that's why a hazardous plant would use a UVR. Shutdown has to be a sure thing.
So you either risk failing to protect, or you risk an unnecessary loss of service.
You see, it's not about which device is technically better. It's all about choosing which kind of failure you're willing to accept for a specific job.
So what's it going to be? Power that won't turn off or an unexpected blackout?